Okay, so this video is on the Pythagorean Theorem. If you remember, the Pythagorean Theorem is used to find the missing sides of a right triangle. A and B are called the legs, and C is called the hypotenuse. For any right triangle using A and B as the legs, A squared plus B squared is equal to C squared. But we can also say that leg squared plus leg squared is equal to the hypotenuse squared. So looking at some examples, we're simply going to set up the Pythagorean theorem. All we have to identify is which side is the hypotenuse. So in this first example, this is my hypotenuse, which is my x. So 8 squared plus 13 squared is equal to x squared. So of course, 8 squared is 64. 13 squared is 169. When I add those two together, I get 233 is equal to x squared. To get x by itself, I have to take the square root of both sides. So the square root of 233 is 15.3. 2 operates about the same way, so I'm not going to do that one just now. For the next one, my missing side is a leg. So it doesn't matter if it's A or B. I'm just going to make it B because I like it that way, I guess. So 7 squared plus B squared is equal to 9 squared. I still have to pay attention to which one is the actual hypotenuse. So 7 squared is 49 plus B squared is equal to 9 squared is 81. Subtract 49 and 81 and I get B squared is equal to 32. Take the square root of 32 and I get B is equal to 5.7. 4 operates pretty much the same way. Now, number 5 shows an isosceles triangle. If you remember from geometry, when an isosceles triangle has a line drawn from the vertex angle to the base, it creates 2 right triangles and it bisects the base. So it makes this side 11. So now I'm in this situation very similar to 3 and 4, where I'm simply looking for the missing side. So 11 squared plus x squared is equal to 24 squared. So 11 squared is 121 plus x squared is equal to, and 24 squared is 576. I subtract 121 from both sides and I get x squared is equal to 455. I take the square root of 455 and I get x is equal to 21.3. 6 is a little bit different because I have a trapezoid here. With my trapezoid, my 2 bases are parallel, and if I see it's creating 2 right angles, which is going to help me with that right triangle. So the way it's going to help me is I'm actually going to create an auxiliary line. I'm going to draw an auxiliary line right here, creating a rectangle. If this is a rectangle, it means this side is 5, and this side is also x. If that side is 5, then 18 minus 5, well, this is 13. And now I have a right triangle with the sides 13x and 16. So I can set up my Pythagorean theorem. 13 squared plus x squared is equal to 16 squared. 13 squared is 169 plus x squared is equal to, and 16 squared is 256. 256 minus 169 is 87. So x squared is equal to 87. The square root of 87 is 9.3. So x is equal to 9.3. All right, number 7 is a little bit different. And this one I actually have at least 2 right triangles. So I'm going to have to find this side and this side and then add them together. So my blue side I'm going to call A. I'm going to call it not A because that's part of my Pythagorean theorem. So I'm going to call it B for blue. And my green side I'm going to call it G for green. So 14 is my C. So 14 squared is equal to the blue squared plus 12 squared. And then for the green, I would set it up as 12 squared plus my green squared is equal to 29 squared. And I'm going to have to solve both of these individually. I'm going to have to solve for B and solve for G and then add them together. So 14 squared is 196 is equal to B squared plus 144. Subtract 196 and 144 and I get 52 is equal to B squared. So B is equal to the square root of 52. And I'm not going to get a decimal just yet because I'm about to use it again. On these others, I was done with my problem, so that's why it was okay for me to get a decimal. If I'm going to continue to use that number, I don't want to get a decimal just yet. So for the green one, 12 squared is 144 plus G squared is equal to, and 29 squared is 841. I'm going to subtract 144 and 841, and I get G squared is equal to 697. So G is equal to the square root of 697. So I'm going to take the square root of 697 and I'm going to add it to the square root of 52. And I'm going to get, when I add them together, 33.6. Okay? So that's a breakdown of the Pythagorean theorem. Word problems with the Pythagorean theorem are not difficult. You just have to draw the right triangle. So a roofer leans a 16-foot ladder against a house. So what does that look like? So a 16-foot ladder against a house. So this is my ladder. And it's 16 feet. And it's against the house. The base of the ladder is 5 feet from the house. So 5 feet from my house is the base of the ladder. How high up does my ladder go? So again, the Pythagorean theorem. 5 squared plus x squared is equal to 16 squared. 25 plus x squared is equal to 16 squared, which is 256. Subtract those two numbers, I get x squared is equal to 231. The square root of 231, so x is equal to 15.2. There's not much difference in all of these. You just have to actually draw the picture and see what type of Pythagorean theorem is going to come up with. Okay? And that's going to be the end of this video.